Okay, I wanted to finish up section 11.2 in this video. We're talking about linear functions. A linear function is a line. It's a function of the form f of x equal mx plus b. Okay, and we looked at some examples earlier where we were graphing a line and working off of the slope and the y-intercept. There's a couple of problems at the end of the section here that is more kind of just application problems, so I thought we'd look at maybe two of those. Problem 16, a community college charges each of its students a registration fee. Students also pay a tuition fee for each academic unit that they take. Last semester, Roger took 9 units and paid a total of $1,439. Last semester, Roger's friend Dennis took 15 units and paid a total of $2,315. Okay, part A, find a linear function f of x equal mx plus b whose input is the number of units taken by a student and whose output is the total fees paid. All right, well, let's see here. So I need to find the slope and the y-intercept on this line, and I'll write my answer in the form y equal mx plus b. So now the information that was given here about these two people are really them describing 2 points that would be on the line. X is the input, right? That's the number of units taken by a student. And then Y is the output, would be the amount that they paid for that semester. Okay, Roger took 9 units and paid $1,439. So basically they're saying, you know, if you plug 9 into the function, this is the output value that you get. Or the point, 1,439 would be a point on this line. Dennis took 15 units and paid $2,315. Okay, so if I plug 15 into this formula that I'm supposed to find, I get like, here's the output. And I would also know, you know, a corresponding point then that would be on the line, 15, 2,315. Okay, now I'm not actually going to draw the line here, okay, but these 2 points would be on that line. And that allows me to compute the slope of this line, change in y over change in x. So if we take 2,315 minus 1,439, we're getting 876 in the numerator. And then divided by the difference in the x values, 15 minus 9 is 6 in the denominator. And if you then take 876 divided by 6, 146 would be the slope of this line. Now that I know the slope, m, I need to find the y-intercept, b, and I can use either one of these 2 points. It's not going to matter which one. They're both on the line. So why don't we just use the first one here, 1,439. Okay, so I plugged in, here's x equal 9, y equal 1,439, and I can begin solving for b. 146 times 9 is 1,314, and if you subtract that number then from both sides, the b value would be 125. Okay, so I know m, I know b. Y equal mx plus b for this problem means that y is equal to 146 times x plus 125. Using function notation then, f of x would be 146x plus 125 then. Okay, and that'd be the answer then to part A. Part B, in your own words, explain what the slope and the y-intercept of this function represent. Okay. Well, the x, by the way, is the number of units that somebody is taking for that semester. Y is the amount that they would be paying for that semester. So the 146 would be the cost per unit. All right. Now, the b value, earlier in the problem here, it says that a community college charges each of its students a registration fee. There's also a tuition fee, which we've already figured out is $146 per unit. Okay, now they didn't tell us this registration fee, but we can now be able to figure out what that amount is. It's $125 up front. Okay, so in order to begin registering, you need to pay the fee of $125. Once you've paid that fee, then you can then, plan to get your schedule ready, and it'd be $146 per unit that you're taking. Okay, Part C, use the function that we found in Part A, this guy here, to find the total fees paid by a student taking 18 units. Okay, well, X is the amount of units, right? So I would just plug in that number into this formula that I've created. 146 times 18 is 2,628. If you add 125 to that, this student would be paying $2,753 then for the semester in order to take 18 credit hours. Okay, problem 17 is the last one then in this section. It says the freezing point of water is 0 degrees Celsius on the Celsius scale, and then 32 degrees Fahrenheit on the Fahrenheit scale. The boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. Part A, find a linear function, f of x equal mx plus b, whose input is a Celsius temperature and whose output is the corresponding Fahrenheit temperature. Okay, well, the freezing point of water is 0 degrees Celsius and 32 degrees Fahrenheit. Okay, so I would be able to conclude that 032 would be 1 point on this line here. The boiling point of water is 100 degrees Celsius and 212 degrees Fahrenheit. Okay, so here's another point that would be on the line. Now I'm not going to draw the line, okay, but I would be able to know 2 points that would be on this line, and I could then be able to figure out the slope of this line. Well, change in y over change in x. So if we take 212 minus 32 for the difference in the y values, divide that by 100 minus 0 for the difference in the x values, then 180 divided by 100, when you reduce that, that'd be 9/5. Okay, so the slope of this line is 9/5. Now this point here is 0.32 is actually the y-intercept. Remember, how we calculate a y-intercept is we let x be 0 and we find y. Okay, so all I would need to do to get the b value is just pick off the y-coordinate value on this point here. B is 32. The function that we need then is f of x equal 9/5 x plus 32. Okay, and that'd be the answer to part A. Now this function will give you the Fahrenheit temperature for a particular Celsius temperature. So part B, it says the lowest temperature ever recorded in Illinois was negative 38.9 degrees Celsius. What is this in Fahrenheit degrees? Okay, well I would just plug in that number and then go to the calculator and simplify. So if we take, let's see here, negative 38.9 times 9/5 and then plus 32, I'm getting negative 38.02 degrees Fahrenheit. Okay, so that'd be the answer to part B. Part C, the highest temperature ever recorded in Illinois was 47.2 degrees Celsius. What is this temperature in degrees Fahrenheit? Well, again, that'd be just to plug it in and simplify, right? So if we take 47.2 times 9/5 plus 32, I'm getting 116.96 degrees Fahrenheit. Okay, and if I wanted to know what any temperature in degrees Celsius would be in degrees Fahrenheit, I could use this formula here. All right, well that's it for this section. So be sure to look at the problems that are on 872 for me, the odd numbered problems listed here.